Hello and welcome to the maths class. Today we are going to do exercise 1.1. In the earlier class we had learnt about chapter 1 real number, in which we had learnt about Euclid's division lemma and how to use that lemma in the division algorithm to calculate HCF. Today we will be doing all the questions in the exercise one by one, so please stay tuned. So question number 1, as it states, you can see on your screens, use Euclid's division algorithm to find the HCF of. First part is 135 and 225. First part is 135 and 225. So this is the solution. Please, you can write it down in your notebooks, or you can just pause the video and see. Since 225 is greater than 135, thus according to Euclid's division lemma, EDL, I'm writing it in short form. Please keep that, please state the full thing. Euclid's division lemma, EDL, we get A is equal to BQ plus R. Now you can just write down, instead of A, 225 is equals to 135 into dash plus dash. Now here you have to find quotient and as well as the remainder. So if we do it by 2, the number is greater than this, that is according to this, if we multiply it by 2, so it will be coming as 270, which is greater than 225. So it cannot be divisible by 2. So we can say that we can divide it by like we can multiply 135 into 1, and the remainder that we'll get is 90. So the remainder is not 0, so you can write as R is not equal to 0, applying Euclid's division lemma. I am writing in very short, please आप उसको full form में लिखें. सो वापस यहाँ पर हमने देखा कि R 0 नहीं है, सो उस केस में हम क्या करते हैं, वापस यूक्लिड्स डिविजन लेमा लगाते हैं B and R पे. सो लेट अस B becomes dividend and R becomes divisor. 90 into 1, अगेन 2 नहीं कर सकते क्योंकि वो बड़ा नंबर आएगा 135 से, प्लस 45 would be the remainder. आप इसको करके देख सकते हैं 90 into 1 and you have to just see that 135 में से कितना बचेगा. So simple, 135 minus 90 is 45. Again the remainder is not 0, as R is not equal to 0, applying Euclid's division lemma on 90, 45. यहाँ पर भी प्लीज आप लिखना मत भूले, on 135, 90. Perfect. So 90 becomes a dividend and 45 as divisor. For into, we know that 2 is 90 plus 0. So as R is equal to 0, we can say that HCF of 135 and 225 is 45. So this will be our HCF. You can find out easily. अगर आपको चेक करना है कभी भी, आप अभी you're using it in a fresh manner, अगर आपको आंसर वापस चेक करना कुछ बड़े नंबर में अगर है, तो you can just go into your rough segment, और rough segment में आप आंसर एक बार चेक कर लेंगे. 135 225 हमने सेम यूक्लिड्स डिविजन लेमा ही यहाँ पर भी वही कर रहे हैं वापस. 135 पीछे बचा 90 becomes a divisor. 135 90 पीछे बचा 45, 90 आ गया यहाँ पर, 2s are 90 और 0. ये हमारा HCF है. देखिए, so this is our HCF 45. This is how you will find out HCF of 135 and 225. Second part says 196 and 38220. 196 and 38220. So since same methodology, this is the solution. Okay, since 38220 is greater than 196, A is equals to 38220 and B is equal to 196. Thus, according to Euclid's division lemma, I'm writing in short form. Please do note that please you have to write it down in the full form. Euclid's division lemma. Please iske short abbreviation मत use करें. It's not a good thing. So we have A is equal to BQ plus R. So what we have A here, 38220 is equals to 196 into dash plus dash. So what will come over here? So when you'll see the division, आप इसको even simpler तरीके से यहाँ पर आप कर सकते हैं. 38220 divided by 196. अपने रफ सेगमेंट में आप इस तरह से करके देख सकते हैं. कोई भी क्वेश्चन हो जिससे आपको पता लग जाए कि ये पूरी तरह से डिवाइड हो रहा है, नहीं हो रहा है. अगर नहीं हो रहा है तो अप्रोक्सीमेटली कितने टर्म्स हो रहा है. सो इट वुड बी इजी फॉर यू टू कैलकुलेट द थिंग. ओके, सो यू 196 into 195 R is 0. So as R हमारा 0 आ गया, सबको लगेगा फर्स्ट स्टेप में 0 कैसे आ सकता है. तो इट्स नॉट अ प्रॉब्लम. फर्स्ट स्टेप में कभी कभार 0 आ जाता है. द रिमाइंडर 0, नो प्रॉब्लम इन दैट. सो 38220 196 into 95. सो हमारा HCF क्या हो गया? 196. Thus as R is equal to 0, we can say that HCF of 196 and 38220 is 196. So this is your answer, and this is how you have to write it down every time that you do the question, these questions, right? Now moving on to the third part. Third part of a question says that use Euclid's division algorithm to find HCF of 867 and 255. 867 and 255. So this is how you have to do the questions, right, in the earlier format. So in the similar thing we'll write solution. Since 867 is greater than 255, A is equal to 867 and B is equal to 255. Using or applying Euclid's division lemma on 867 and 255, we get 867 is equals to 255 into dash plus dash. Here we'll get into 3, पीछे बचेगा 102. तो आंसर यहाँ पर 0 नहीं है. So we'll move it again as R is not equal to 0, applying यूक्लिड्स डिवीजन लेमा. मैं फिर बोल रहा हूँ, शॉर्ट फॉर्म में लिख रहा हूँ, प्लीज शॉर्ट फॉर्म में मत लिखें. 255 and 102. So 255 and equals to 102 into dash plus dash. क्या आएगा? R और Q की वैल्यू प्लीज फाइंड आउट करें जल्दी. 2 से 204 होगा, माइनस करें 255 माइनस 204, पीछे बचेगा 51. Again, as R is not equal to 0, we can say that using Euclid's division lemma on 10251. So 102 is equals to 51 into dash plus dash क्या आएगा into 2 और plus 0. So this buddy over here is our HCF. ये हमारा HCF है. So thus last में हमेशा आपका आंसर इस तरह से एंड होगा. Thus as R is equals to 0, we can say that HCF of 867 and 255 is 51. So here is the answer. This is question 1 हमारा होगा. So what are questions 2 states? See on a screen. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Okay, this is a word problem, and similar types of word problem will be given in your examination. Please note that. And in the word problems you have to find the given context and what you have to find, what you have to show, okay, what you have to prove. So here we have show that any positive odd integer. What? Positive odd integer. Any positive odd integer. So here we can say let a be, I'll just write solution. Okay, let a be any positive odd integer. Okay, any positive odd integer. ये a है हमारा any positive odd integer. Okay, now what it is given, what we have to prove, show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Okay, so what we have to show to prove that a is equals to 6q plus 1, 6q plus 1 or 6q plus 3 or 6q plus 5. Alright, so this is what we have to show. So we have for b is equals to 6 and a as a positive, a as any positive integer, any positive odd integer according to Euclid's division lemma. We can say that a is equals to bq plus r, and here we have a is equal to 6q plus r where r is equals to 0, 1, 2, 3, 4, 5. Because now here comes, हमेशा अपने आंसर को जस्टिफाई करते हुए स्टेटमेंट दीजिए. Because value of r lies between 0 and b, and here b is equals to 6. So value of r lies between 0 and b, and here b is equal to 6. So we have values of r as these. So therefore a is equals to 6q or a is equals to 6q plus 1 or a is equals to 6q plus 2 or a is equals to 6q plus 3 or a is equals to 6q plus 4 or a is equals to 6q plus 5. You can add up in the bracket when r is equals to 0, when r is equals to 1, when r is equals to 2, when r is equals to 3, when r is equals to 4, and when r is equals to 5. So these are all are your scenarios. These all are your cases, right? So case 1, case 2, case 3, case 4, case 5, case 6. So now we can clearly see from here, as we can clearly see in cases A is equal to 6q plus 1, comma 6q plus 3, and 6q plus 5 can also be rewritten as 2 into 3q plus k1 to 3q plus 3, and we can write as 3q plus 1 and plus 1, and here 2 3q plus 2 plus 1. Okay, perfect. So we can say that 2k1 plus 1, 2k2 plus 1, and 2k3 plus 1, where k1, k2 and k3 are any positive integers. So here what we have, we can see that it's can be easily seen in all the three cases that it is of the form 2k plus 1, 2k2 plus 1, or 2k3 plus 1, like 2k plus 1. From the above equation, we can clearly say that as A is equal to 6q plus 1, comma 6q plus 3 and 6q plus 5 are not in the multiples, in the perfect multiples of 2, or of form 2k plus 1, we can say that any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5. Hence proved. So this is how you'll prove the second question. So question number 3, and on your screens you'll have, you can see that an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So herein we can easily see that we have to see that how they can march in equal number of columns, and as they have to parade in a column fashion. So how many members of we can find out easily by finding the HCF, that how many numbers of columns they can march in. So number of, firstly we'll write the given things, number of members in army contingent is equals to 616. Number of members in army band. What are the number of members in the army band? We have 32 members. So to find, what we have to find, the maximum number of columns in which they can march. To find the maximum numbers of columns in which both can march is equals to HCF of members of army contingent, comma, members of army band. So HCF of 616 and 32. So we can see, applying Euclid's division lemma on 616 and 32. Since 616 is greater than 32, we can write as 616 is equals to 32 into dash plus dash. Please find out Q and R first. So here we can say 32 into 19 is 608 and remainder is 8 again. So as remainder is not equal to 0, applying Euclid's division lemma, please write it in the full form, on 32, 8. So we have 32 is equals to 8 into 4 plus 0. As now R is equals to 0, we can say that HCF of 616, 32 is equals to 8. Right. Therefore, the total number, or we can say the maximum number of columns in which members of army contingent and members of army band can march are 8. So this is your answer of the question. You can please jot it down by just pausing the video. This is your perfect answer for the question. Fourth question states that, you can see in your books, use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So what we have to show now, that the square of any positive integer, right? So that we have given, okay. Let any positive integer be a. We need to prove, okay, according to the question, to prove a square is equals to that 3m or 3m plus 1. as b is equals to 3, using Euclid's division lemma, we get a is equals to bq plus r, or a is equals to 6q plus r, and r is equals to 0, 1, 2, because value of r lies between 0 and b, where b here is 3. So case 1, when r is equals to 0, q square is equals to 9q square is equals to, इसको ऐसे भी लिख सकते हैं हम 3 into 3 q square. Okay, let 3q square is equals to m for any integer m. Then we get a square is equals to 3m, as m is equals to 3q square. So this is how we have proved one, a square is equal to 3m. Now in the similar manner, case 2, when r is equals to 1, so we have a is equals to 3q plus 1 squaring, sides please लिखें, a square is equals to 3q plus 1 whole square. अब आपने फॉर्मूला पिछले साल पढ़ा होगा एक x plus y whole square या a plus b whole square का. So we have a square plus b square plus 2ab. So इसको हम evaluate करेंगे, that is 9q square plus 1 plus 6q. Simplest form में लिखेंगे a square is equals to 9q square plus 6q plus 1. कॉमन लेंगे 3 कॉमन आ सकता है इन दोनों में से, 3q square plus 2s are 6, that is 2q plus 1 is equals to 3m plus 1, where because m is equals to 3q square plus 2q for any integer m. अब यहां पर फिर से हमने m की वैल्यू सपोज करी ये, और कोई भी इंटीजर हो सकता है m. सो दैट इज वाई आप इस क्वेश्चन में इस चीज को याद रखें, इसको आप m1 m2 एंड m3 भी लिख सकते हैं, और उसके बाद एट द एंड उसको प्रूव कर सकते हैं, दैट इज इट इज ऑफ द फॉर्म 3m और 3m plus 1. नाउ मूविंग ऑन टू द केस 2. Case 2 we have done. Case 3, where r is equals to 2, we have a is equals to 3q plus 2. Squaring both the sides, again same thing करेंगे हम, squaring both the sides, we get a square is equals to 3q plus 1 2 का whole square. So again moving on to the formula, evaluating the value of a square, so we get a square plus b square plus 2 into a and b. So we have a square is equals to 9q square plus 4 plus 12q. सिंपलेस्ट फॉर्म में लिखेंगे 9q स्क्वायर प्लस 12q प्लस 4 को मैं लिख सकता हूं 3 plus 1. मैंने यहाँ 3 + 1 इसलिए करा है बिकॉज मेरे को 3 कॉमन लेना है, बिकॉज +1 हमें 3m + 1 फाइनली ये वैल्यू प्रूव करनी है, ठीक है, कि एक कोई भी ऑड पॉजिटिव इंटीजर इस फॉर्म में होगा। सो अब हम देखते हैं स्क्वायर किसी और पॉजिटिव इंटीजर का इस फॉर्म में होगा, तो हम इसको देखते हैं a² इज इक्वल्स टू, आप कॉमन ले लेते हैं यहाँ से 3, सो कॉमन के बाद आएगा 3q² + 4q + 1 और बाहर +1। सो ये हमारे पास आ गया कॉमन। इसको अगेन हम सपोज करेंगे या लेट करेंगे या अज्यूम करेंगे एक वैल्यू m इंटीजर की, क्योंकि m is any integer or any integer m, we have this value. So we can state that a² is equals to 3m + 1, where m is equals to 3q² + 4q + 1 for m is any integer. Thus, आखिरी में प्लीज इसको इस तरह से लिखना ना भूलें, thus from above equations we see that the square of any positive odd integer is of the form 3m or 3m + 1. Hence proved. So this is your answer for the question number 4 of exercise 1.1. You can please pause the video and jot it down. Now moving on to the last question of the exercise, question 5. What question 5 states, let's see on the screen. Use Euclid's division lemma to show that the cube of any positive integer is of the form 9m or 9m + 1 or 9m + 8. Same question, बस यहाँ पर हम a जो लेंगे वो है एक पॉजिटिव इंटीजर. लेट a be any positive integer. First let a be any positive, इसको प्लीज आप फुल फॉर्म में ही लिखें, पॉजिटिव integer. Then according to question, to prove a³ is equals to 9m or 9m + 1 or 9m + 8. So this is what we have to prove. Now let b is equals to 3. Applying Euclid's division lemma, please full form लिखें, मैं short form में लिख रहा हूं यहाँ पर. Euclid's division lemma on a and b, we get a is equals to 3q + r as b is equals to 3. We have r is equals to 0, 1, 2, because value of r lies between 0 and b is equals to 3. तो 0 और से b के बीच में लाई करती है वैल्यू ऑफ r, और r की हमारे पास 3 वैल्यू है. सो लेट अस स्टडी द केस 1. केस 1, when r is equals to 0, a is equals to 3q, cubing both sides, we get a³ is equals to 3q whole cube is equals to 27q cube, and we can write this 27q cube, इस 27q cube को, क्या ये 3m या इस फॉर्मेट 9m के फॉर्मेट में दिखता है आपको, तो इसको इसी फॉर्मेट में लाना है, वही हमको पार्ट करना है जो हमने पिछले क्वेश्चन में करा था। 9 कॉमन ले लेते हैं, 3 = 27, q पीछे आ गया, इसको हम 9m1 लिख देंगे, where m1 is equals to 3q cube for value of m1 is any integer. So this is our statement 9m1. Okay, now seeing the case 2, I'll write over here because अब थोड़ा सा ज़्यादा होगा because formula लग रहा है। Case 2, when r is equals to 1, we have 3q plus 1 and cubing both the sides, cubing करेंगे, a cube is equals to 3q plus 1 whole cube, फॉर्मूला हमने पढ़ा था a plus b whole cube का, वो लगेगा a cube plus b cube plus 3ab a plus b। तो प्लीज इस फॉर्मूले को ध्यान रखना, और अगर कभी फॉर्मूला भूल जाओ तो उस केस में सेपरेटली इसको मल्टीप्लाई करना, दैट इज 3q plus 1 ब्रैकेट 3q plus 1 3q plus 1। आपका आंसर तो भी सेम आएगा, बट उसमें कैलकुलेशंस आपको बिल्कुल ध्यान से करनी होगी, थोड़ा सा ध्यान से आप कैलकुलेशंस करें। सो विल राइट डाउन इन द फॉर्मूला, we have a as 3q and b as 1, so we have a cube 3q cube plus 1 cube plus 3ab a plus b, so a cube is equals to 27q cube plus 1 plus 9q into 3q plus 1 is equals to 27q cube plus 1 plus 27q square plus 9q. We can write it down into simpler format, 27q cube plus 27q square plus 9q plus 1. So can we say that we have in simpler form, and क्या ये 9m plus 1 या 9m plus 8 के बराबर है? So we can say here 9m plus 1, we have plus 1 over here, right? We can easily say that. So 9 एक बार हम कॉमन लेके देखेंगे, so a cube is equals to 9 ब्रैकेट में 3q cube plus 3q square plus q plus 1, and we can state that 9m2 plus 1, where because m2 is equals to 3q square plus 3q यहाँ स्क्वायर नहीं है, 3q cube plus 3q square plus q for m2 is any integer. So इस तरह से आपने यहाँ पर एक और चीज प्रूव करी, 9m2 plus 1, that is 9m plus 1 के फॉर्मेट में हमने इसको प्रूव करा है, and here you can clearly see that. Now seeing the final case, that is case number 3, when r is equals to 2, so a is equals to 3q plus 2, a is cubing both the sides, we get a cube plus 3, a cube is equals to 3q plus 2 whole cube. Now opening with the formula x cube plus y cube, that is x cube plus y cube plus 3x y into x, plus y. So now we can simplify the question. 27q cube plus 8 plus 9 into 2, 18q and 3q plus 2. Okay, so 27q cube plus 8 plus 54q square plus 36q. Writing in simpler format, 27q cube plus 54q square plus 36q plus 8. अब देखते हैं हमारे पास 9m plus 8 ये फॉर्मेट में है कि नहीं है. 9m plus 8 हमारे पास यहाँ पर 8 हमको यहाँ पर नजर आ रहा है. So what we can do, we can again take out 9 as in common. 9 as in common, what we'll get? 3q cube plus 6q square and plus 4q plus 8. So we can say that 9m3 plus 8, because m3 is equals to 3q cube plus 6q square plus 4q, and m3 is any positive integer. Okay, so the final statement of this question, the final statement,
thus from the above equation we can see that a cube is of the form 9m or 9m2 plus 1 or 9m3 plus 8, where m1, m2 and m3 are any integers as we had already discussed. Therefore, we can say that the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8, hence proved. So this is how you have to deal with all the questions and the word problems related to Euclid's division lemma. Apart from that, if you have any question, please write it down in the description box below. And if you have any problem related to the content of the material, please also do write it into the description box. Thank you. Please subscribe for the more upcoming and new videos. And I would be like to serve you in a very well detailed format. Thank you.